In this video, we're going to be talking about the voltage divider. What the voltage divider circuit is a voltage source with two resistors in series. And the goal of the voltage divider equation is to relate VO, the point between these two resistors, to R1, R2, and VI. And the reason we do this is because this circuit is something that shows up a lot in electrical engineering. And it saves time to know how VO relates to R1, R2, and VI. So let's begin by deriving that relationship. And the first thing I'm going to do is draw the current for my circuit. So we only have one current, we can call this I1, and it's going through all of my components because everything is in series. And this is actually the biggest mistake I see with this circuit. For instance, if you had a situation where you had a resistor and a voltage source coming out the side, the voltage divider equation would no longer be valid. And that's because it's something that is derived for a specific circuit, and changing that in any way is going to lead you to the wrong answer. So now that we've defined our current, the next thing I need to make sure is that I've labeled my node voltages. This node here is already labeled VO with respect to ground, but I have to label this node as well, and we can call this VI. And that's because our source VI is referenced to ground. So now that I've labeled my nodes, I'm going to write the equations for my components. And we'll start off with the equation for R1. And that's going to be an Ohm's law equation that says I1 is equal to VI minus VO divided by R1. Now moving on to R2, we can say that I1 as well is equal to VO minus 0 divided by R2. Now what I'm going to do is, because both of these are I1 equations, I can equate these two together, and I'll have that VI minus VO divided by R1 is equal to VO divided by R2. And I can multiply both sides by R1 multiplied by R2, and this is going to give me VI R2 minus VO R2 is equal to VO R1. Now let's move our VO terms to the same side, and I'll have that VI R2 is equal to VO R1 plus VO R2. And now I can factor out VO, and this will give us that VI R2 is equal to VO multiplied by R1 plus R2, and we can divide out by R1 plus R2, and we end up with VO is equal to VI R2 divided by R1 plus R2. Now that we've derived the voltage divider equation, let's plug in some values. We can make this 10 volts, we'll set R1 to be equal to 9K, and we can set R2 to be equal to 1K. Based on these values, VO would be equal to 10 multiplied by R2, which in this case is 1K, divided by R1 plus R2, so that'll be 1K plus 9K. And the K's cancel out, and this is going to be equal to 1 volt. And that is all there is to voltage division. The biggest thing to keep in mind when using it is just to make sure that your components are in series. If you enjoyed this video or found it helpful, please like and subscribe. I'll see you next time.